at quadratic functions and graphing them. And we know that quadratics can be used to model real life situations like projectile through the air. We're going to learn how to solve them graphically and algebraically. So that's finding x-intercepts. And if you've learned how to factor before, you're going to have a whole bucket of skills. You're going to learn how to factor using 4 different strategies, using square roots, using the quadratic formula. If you were in advanced, we also have completing the square. So if you're moving on to pre-calculus, maybe in the future, you would see another strategy. So finding the best strategy in any situation. And we'll also see that quadratic functions might have no solution, one solution, or 2 solutions. Moving on in math, if you've ever heard of imaginary numbers, they would come into play in this unit. We're skipping imaginary numbers, but in advanced, they're going to look at that, and in pre-calculus, they're going to look at that. So there's a lot of foundation stuff in Unit 3, solving quadratics. So the first thing I want you to look at is this resource page. We don't have a lot to write up here. I just kind of wanted to frame the unit out. The big idea is to find solutions to a quadratic. And it's important to know all these synonyms. So it really just means you're finding the x-intercepts, but they could also be called solutions, roots, zeros, or x-intercepts. So if you're on the SAT and all of a sudden they're asking you find all the roots of this equation, you might know how to do the problem, but you might have no idea what roots means. So just knowing we are learning the strategies to solve for this. So if I ask you to find the solution, the root, the zero, or the x-intercept, you're using these strategies. That all means the same thing. And then these are all the strategies we're going to kind of look at to be able to do this. So this is kind of connecting this unit to last unit. If you were going to solve a quadratic by graphing, you would look to graph the quadratic. We should know how to do that, vertex form or standard form. You're just looking at the function, y equals x squared minus x minus 2. This is the graph of it. What are the x-intercepts on here? -1 and 2. So the x-intercepts are -1, 0, and 2, 0. If I'm looking for x-intercepts, I write them as coordinates. This same exact equation, how is it written differently here? Now it's written as a quadratic equation that's equal to 0. So to find the solution to this equation, you really know what makes this equation 0 when x is -1 and when x is 2. So you write your solution as x equals -1 or 2. Same answer, but in the past we were just recording that they were x-intercepts. Now we're saying those are the solution to our problem. At -1, the y value is 0. At 2, the y value is 0. So what would be how would I write it out for the second one there? What's my x-intercept? Okay, we had trouble with this on the test because some people thought for it to be an x-intercept, it has to cross over. Technically, it just has to touch the x-axis. It may not cross over, so that counts as an x-intercept. So my solution to this problem is just x equals 5. Yeah. No, 2 here. So do you see how this had 2 possible answers? This only had 1 possible answer. Question? Okay. All right, what about this one? Now I got a concave down parabola, but does that change how I find x-intercepts? No, I find them the same way. So my x-intercepts are 1, 0, and 3, 0. So I would write x equals 1 or 3. So it's just taking it one more step from what we did last unit. Can you graph the quadratic and find the x-intercepts? What are the x-intercepts on this fourth example? There are none. So how many solutions will there be? Can this equation ever equal 0? The y value will never equal 0. So there is no solution either. So if you've got a floating parabola that never touches the x-axis, right, you never touch the ground. So think of like real world. I launched my water balloon from 1 meter. That's when I was on the ground. I reached my peak and now I hit the ground again. So think of this as the ground. I'm not sure. Maybe this is like a yo-yo. So like, what's the height of the yo-yo over time? It goes down and then I like, jerk back up at 2 feet from the ground. And now the height of the whatever yo-yo is going back up. The yo-yo might never touch the ground, right? All right. So I think that is it. This page I'm not going to look at too much, but we're going to talk about like when we get into factoring and you've got all these different strategies to help you narrow down your choices. So I'll keep coming back to this page. Like, what should I do first? Okay, now what possibilities do I have? So this is the page I might start with tomorrow, and I'll post a video, and you can just do it at home. Okay, but now I want to turn ahead to page 301, because this was kind of what we talked about last unit. If you've got a quadratic application problem, right, the ball is being thrown up in the air. The y-intercept is where it starts from, 3 meters above the ground. It has a certain velocity. It goes up, comes down. If we have an equation to model this situation, we can look at its graph. What does the graph show the ball hitting the ground after? How many seconds until the ball hits the ground? 3 seconds. So this just says we will learn strategies on how to solve this algebraically this unit, because we would have to graph this. Think about, it would be kind of challenging to graph this equation, right? Negative b over 2a. How many seconds have passed that I'm at my highest point? This was on your test. So you would do negative 14 divided by negative 10 would be 1.4 seconds. Doesn't that look like about 1.4 seconds? And what's the highest point? I can't really tell. Somewhere between 12 and 13, right? I'd have to plug it back in. So we're going to learn how to connect what we did last unit to this unit. So this just says, let's complete a couple more solve by graphing examples for practice. So this should help you review. If you did super well on the unit test, we're going to graph the quadratic, and then we're going to figure out what the solution is. So let me try number 1, and let me try number 6. 1 and 6, and then you try the others kind of before lunch. So I would think of this as vertex form, right? I don't move left or right. What does this negative 4 do? Down 4, outside, down 4. So I'm putting my vertex here. There's a 1 in front of the x squared. So I'm just going to do the parent function, right? Over 1 up 1, over 2 up 4, over 3 up 9. I don't have to stretch my parabola. And you guys worked these really well on the test. 1, 1, 2, 4, that actually hit my x-intercept perfectly. And then over 3 and up 9. So if you didn't understand how to graph a quadratic last unit, you're going to miss one of your strategies right out of the gate. So we have to know how to graph quadratics. This says solve by graphing. I need to record the solutions to this quadratic. So what are my x-intercepts? -2 or +2. So make sure you record your solution. We haven't had to do that in the past. All right, I'm going to let you try a couple on your own, but let's do one of the, let's do number 6 together, because that's standard form. And then you should be able to try some of these practice problems, and I can come around and help you. But this literally is a review of last unit. I do negative b over 2a on this one, right? Negative b over 2a. What is negative b on this example? Negative 4 over, and what is 2a? 2 times 2 is 4. My x value is -1. Why don't you try plugging -1 in your head and just see what we get? So if I plug in -1, see if you can add them up in your head. Like this would be 2, right? Just 2, because -1 squared is 1. So I have 2 from here. This guy would give me -4, and this guy would give me +3. This should seem very familiar to you, like we just took a test on this. So +1, does that look right? -1 for x, +1 for y. All right, well, that is right here, which is above the x-axis. So if I just graph one set of points, I'm going to show that there is no solution, right? Because this is steeper times 2, but it's concave up. So if I go over 1, up 2, I'm up here. For the sake of review, what's the second set of points for this parabola? It's not over 2, up 4, because it's twice as steep. So it's over 2, up 8 would put me, what, at 9? Because I'm starting at 1. So this is a steeper parabola. It never hits the x-axis, so I need to write no solution. Because the directions were find the solution to these quadratics. And we know solution means find the x-intercepts. So can you try, there are like 4 more graphs. You're welcome to check your answer on the graphing calculator to see if your x-intercepts are correct. And then there's just a couple problems like foiling out again. We need to be good at FOIL, our box method. And then this is like, what are the x-intercepts from this application problem? So I think in about 15 minutes, you guys should be able to be finished with kind of phase, kind of page 1 of graphing.